Worldwide, more than 2.6 billion people are affected by parasites called helminths. The main contributors are due to poor irrigation, the use of polluted water for irrigation, and the disposal to land of excreta or sludge. These parasitic worms are transmitted through their eggs. The Engineering Institute developed a project to address this problem, led by PhD Blanca Jimenez Cisneros.
Well, I have prepared my PhD in France long time ago, and when I went there, my PhD was on how to remove nitrogen and phosphorus from wastewater. I work a lot on that. I developed a method to remove and even a mathematical model for that. When I came back to Mexico, I wanted to remove nitrogen and phosphorus from all the wastewater in Mexico, but soon I had a meeting with experts from the centers to fix nitrogen in the soil, and they told me that my PhD was very interesting, very valuable, but in Mexico was not useful at all. Almost all the wastewater, because we are in a semi-arid and arid regions, goes for irrigation. But then I start to analyze which was the problem on using this wastewater not treated for irrigation, and soon I find out that the main problem was the spreading of diarrheal disease, notably those diseases caused by worms, which are called technically Helmint eggs. So I started to understand and learn about these Helmint eggs, the eggs of these helminths, and it turns out that these eggs are the most difficult or resistant particle that an environmental engineer has to deal with. So I started to learn how to kill them. I learned different methods to kill them and to remove them from water. But then the question was to know if I was doing in the amount necessary and if I was removing all these Helmint eggs from wastewater or from other type of samples.
Even though criteria and regulations to limit their density in environmental matrices exist, their application relies on the capability to correctly identify these eggs by direct observation at the microscope.
I start to learn about the different analytical techniques that could be used to measure these Helmint eggs, and it turns out that all these methods were very old. Microbiologists has to be very, very skilled because you have different type of worms, several species, and of each species the egg can be in different stage of development, and you see them in the microscope and they are very different. So this was the main source of error, and it turns out that with now all these new methods that are available in which you can make a recognition, a software to recognize different patterns, this principle could be applied to these techniques, which is making us to reduce the cost for the analytical techniques, but also to increase the efficiency and the accuracy of the test.
Due to the complexity to classify the different types of Helmint eggs, a software was developed that allowed their identification in a faster and more accurate way.
Well, the principle of the way in which all this system works is very simple. You take one sample of wastewater, then you need to start separating the different type of particles that you can find on wastewater. Just think in wastewater you can find anything. And even in some cases when you are looking at a sample, a bubble of air can look like a Helmint egg. So for you to see how this can be very challenging. So first you try to clean the sample, and then at the end you take a photograph. You can send it through using a mobile. It goes to a central laboratory, and the central laboratory runs the software, and then you receive back in your cell how many Helmint eggs and which types you have or not in your sample. Well, that is putting us in a leading position at the world level, because we are the only ones having this type of procedure and software, and then it's the only one. We are really solving a problem for billions of people. We are allowing very poor communities to have a tool in which they can take a simple sample, send it to a central laboratory, and then they can know how many eggs they can have.